Hey guys, welcome back. This is going to be for Algebra 1. This is going to be lesson 98, solving quadratic equations by factoring. Thank you so much for tuning, for your overwhelming support. Last time I checked, I had 14 followers. Not followers, 14 subscribers. My bad. This is not Instagram. So you know, I'm getting there. Getting to be a very famous YouTuber now. Probably gonna have to stop tutoring in the summer or something just to dedicate myself to this. I'm just kidding, obviously. But today we're gonna do solving quadratic equations by factoring, and this is what I was talking to you about during class time. That you need to know how to do factoring in order for you to know how to solve quadratic functions. And this is why we did the whole thing. And so let's actually dive into this. This is going to be something that if you know how to factor, it's not going to be that hard. Okay, so let's dive into the first example. The first example is x minus 4, x plus 5 equals 0. So in here, they're telling us solve for x. What does it mean? So we have to solve for the x's here. And there's one thing called the zero property. The zero product property, or the zero multiplication property, in which if we say that this is 0 times this, it would be 0. That makes sense. And if we say that this is going to be 0, then times this, it would be 0. Because 0 times any number is going to be 0. So what we're going to assume is that either this or this is going to be 0. So the way to solve it is to remove this right here, this second binomial. And so it will be x minus 4 equals 0. And so just solve for x. We're going to add x to both sides, and x is going to be 4. So we found our first one. Or we're going to say what happens if it's the other one that is 0. So x plus 5 equals 0. X equals negative 5, because we subtracted 5 both sides. So we solved for x. X equals 4 or x equals negative 5. And that would be the first part of the first example. The reason we're going over the zero product property and finding what x is when this equals 0 is because this is how we find the zeros. And if you actually understand in a quadratic function, when you have x and y, and we have a parabola, it doesn't matter if it opens upwards or downwards. Right here, this is a 0. Right here, this is 0 when x equals 0. So what we're saying is for this to be 0, or for y to be 0, actually, not x, but y. For y to be 0, so it doesn't even go up or down, it just stays here and goes left or right from the origin. So for that to happen, then we have to find where it happens in the in here, in the two binomials. And so in one it's 4, and then the other negative 5. So I'm just giving you an example of why it's important for us to be able to solve for x when we have equals 0, because that would give us the zeros, or how many times the graph is going to touch the x-axis. And remember, a parabola can have 2, it can have 1, or it can have no x-intercepts, and that's important to know. All right, so in the second example, we say find the roots. I put zeros in parentheses because a lot of times what happens is that we don't even know what the roots are, and then they tell us, okay, find the roots, but we don't know. So it's the zeros. So they're asking us, this is a quadratic function, Yes, it's a quadratic function. How come? Because it has an x squared, a quadratic term, it has a linear term, and it has a constant. And then we're going to make that equal to 0. And that is going to make us be able to find the roots. And the roots is when y equals 0. That's why it doesn't matter that we don't have a y. The y has to be 0 for us to be able to find the roots. That's why it's actually called zeros. And I like zeros a lot more. But your book is going to mainly say roots. And I think in the math world, they actually say roots a lot more. But zeros, it's also in another term that we can use to be able to find this. So to be able to find it, we're going to move the 8 to this side, and because this is positive and we have to move it to this side, so it's become 0, we have 2 subtracted. So it's going to be x squared plus 2x minus 8 equals 0. Now, this is important. This is where we're going to factor. Now, this is going to be an easier factoring because we don't have a coefficient in the first term. So to factor, we just need to know the factors of 8. And the factors of 8 are going to be 4 and 2. Because the 2 is positive here, it's going to be plus 2 minus 2. Done. I'm done factoring, but that's not the answer. The answer is going to be x plus 4 equals 0 to solve for x. So x is going to be either negative 4 or x could also be positive 2. And so the zeros are x negative 4 or x equals 2. And those are the two zeros. Sorry, your book doesn't say or, it says and. So the roots are x negative 4 and x equals 2. And that would be the first part of example 2. Well, I realize that some of you can see the negative 4, so I'm just going to make a quick shot just showing you that it is negative 4. And so it'd be x equals negative 4 and x equals 2. So the second part of the second example is, again, find the roots of 7x squared minus 6 equals 19x. So again, we're going to move all the terms to the left, and then we're going to factor. So the first thing that we're going to do is move the 19x over here. Because it's positive, it's going to be negative. So it's going to be, when we move it, it's going to be negative. That's what I meant. 19x minus 6 equals 0. Because we subtracted 19x on both sides, and now we get this. Now, pay attention, because in here we do have a leading coefficient. So one of them is going to be 7x, and the other one is going to be just x. Now, because it's negative and negative, one of them is going to be positive, the other one's going to be negative, but I don't know yet. So my factors for 6 are going to be 6 and 1 or 2 and 3. That's it. I don't really have anything else. So we can try with 6 and 1, but 7 times 6 is 42, way over 19. And 7 minus 6 is negative 1 or positive 1, which is going to be still way over 19, way less than negative 19. And so let's try 2 and 3. 7 times 2 is going to be 14. 14 plus 3 is 17. So that's not it. But 7 times 3 is 21 minus 2 is 19. So what we're going to do is going to be 7x minus 3 plus 2. And that would be what we have to factor there for. And so then it's going to be 7x plus 2 equals 0 and x minus 3 equals 0. So here 7x equals negative 2. X equals negative 7, negative 2 sevenths, right? And then in here is going to be x equals positive 3. So my zeros are not or, but and. Negative 2, 7, and x equals 3. You can put it like this, or you can put negative 2 and 7. Let me just check real quick that you guys can see that. Yeah, that's perfect. And that would be the end of example 2b. All right, and then the final example that I'm going to go over today is going to be example 3, which says find the roots by factoring first through finding the GCF, and then you factor. So the first thing I'm going to do is I'm going to make this all go to one side. I know that in the book they have it all in the left, but I don't understand why they do that, because I know it's going to be the same thing. I know. But I'm going to actually move it all to the right in my example, because negative 2x squared, which is my quadratic term, is negative here. So I want to turn it over here to be positive. So it's going to be added to this side. And so it's going to be, I'm going to do it one step at a time. 2x squared plus 70 minus 20x. I know that's not the correct order to write the polynomial yet, but it's because I have the 20 here. Once I move the 20 over here, I'm going to write it the correct way. And so to be able to move the 20, because it's positive, I have to make it negative. Why negative? Because I subtract 20 from both sides, and that's why it becomes negative. And 70 minus 20 is 50, so that it makes it a lot easier. So my final polynomial, trinomial actually, is going to be 2x squared minus 20x plus 50. Okay, so in here, all of these are divisible by 2. Yes, by 2. And so we're going to actually divide 2 from all of these. And so it'd be x squared minus 10x plus 25. This is going to be really easy because this I already know. Okay, I already know it's going to be x minus 5, x minus 5. So it's going to be 2x minus 5, x minus 5. Why? Because I have the trained eye and I know that this is the trinomial of the special product of a binomial. That is the same. All right. So this is something that we've gone before in the lesson, over the lesson. So it doesn't matter. I can't recall the name quite correctly, but it doesn't really matter. So in here, what you're supposed to do is you're going to solve only for one of these, because why would you solve for both of these since they're the same? And you're going to say, but what about the 2? Well, the 2 doesn't matter because this is 0 or this is 0, because 2 times 0 is going to be 0. So it doesn't really matter. The 2 is just there so that it makes it easier for us to find what x is. And in this case, x minus 5 equals 0. X is going to be 5. And that's it. That's the only root that I have in this quadratic function. And so thank you so much for tuning in. I appreciate all the love and support. Obviously, 14 subscribers. That's a lot, obviously, from 0 to 14. That's, huge. And I want to thank all my likers, commenters, subscribers, and I would also ask you that if you enjoyed this video, that you go and like it, comment, and subscribe. Maybe join if you want to, but that's up to you. All right, I'll see you in the next one.